In this video, we're going to be dividing by complex numbers. We're going to show how to simplify it into the form a plus bi. Again, we always want to get into that form for a complex number. So it's a little different than adding, subtracting, or multiplying. So when we divide by a complex number, we want to multiply the numerator and denominator by the conjugate, the complex conjugate of the denominator. And so what that means is if you have the complex number a plus bi in the denominator, we're going to multiply the numerator and denominator by a minus bi. And then we're going to perform that operation of multiplication. We already know how to multiply two complex numbers. And then you're going to simplify to the form a plus bi. So here are two examples that we're going to look at. We're going to have 3 minus 2i over 2i. Now, I know it says to multiply by the complex conjugate, but because we don't have the form a plus bi, we just have the bi piece down here, we're going to get rid of the I in the denominator by multiplying the numerator and denominator both by I. When we do that, I can now multiply numerator and numerator, so that will give me 3i minus 2i squared over 2i squared. And now I'm going to simplify that. We know I squared is negative 1, and so minus 2i squared actually becomes the real part of positive 2 plus 3i all over 2i squared. We know I squared is negative 1, and so 2i squared is the same as negative 2. And so when we took 3 minus 2i and divided it by 2i, our result is the complex number 2 plus 3i over negative 2. And if we really want to write it into the form a plus bi, we would say negative 1 minus 3 halves I. And so now we really know our a is negative 1 and our imaginary part b is negative 3 halves. So again, if you only have an I in the denominator, we're going to multiply numerator and denominator by I, and that will cancel out the I when we multiply it. We'll get I squared, which we know is negative 1. Then we get into the form a plus bi. Looking at example number 2, we have 4 plus 3i, so a complex number divided by another complex number, negative 2 plus 5i. And so again, we need to multiply by the complex conjugate. So I have negative 2 plus 5i, so the complex conjugate would be negative 2 minus 5i. Multiply the numerator by the same value. Now we just do what we did with multiplying our complex numbers. And we're going to FOIL the numerator and denominator. So working on the numerator first, we get 4 times negative 2. We get negative 8. We get 4 times negative 5i, which is negative 20i. We'll get 3i times negative 2, which is minus 6i. And we'll have 3i times negative 5i, which is negative 15i squared. All divided by. Now something magical is going to happen here. Negative 2 plus 5i times negative 2 minus 5i. If you notice, this is actually a difference of 2 squares form. Right? We have negative 2 plus 5i and negative 2 minus 5i. So if I multiply negative 2 times negative 2, I'll get positive 4. I get plus 5i times negative 2i. That gives me negative 10i. I get negative 2 times negative 5i, which gives me positive 10i. 5i times negative 5i gives me negative 25i squared. Now we simplify. We know negative 15i squared, that becomes plus 15, and so negative 8 plus 15 gives me a real part in the numerator of 7. Negative 20i minus 6i gives me the imaginary piece of negative 26i. In the denominator, we have negative 10i plus 10i. Those will cancel. I have 4 minus 25i squared now. this becomes plus 25, and so 4 plus 25 is 29. And so the last thing we need to do is write it in the form a plus bi, and so this will equal 7 over 29 minus 26/29 I. So again, the key to dividing by a complex number is understanding that we need to get rid of the I in the denominator. And so in the first example, we can multiply by I over I, which is just 1. Or we need to multiply by the complex conjugate. Again, negative 2 minus 5i over negative 2 minus 5i is just 1. That will eliminate our imaginary part in the denominator, simplifying to get our final answer in the form of a plus bi.